Hello there. My name is GURUPRASAD. I have been working in IT industry for more than 12 years as a database administrator and as well as data architect. Today, I'm going to discuss about this advanced data warehouse management and optimization strategies with the Teradata. Let me maximize this.
I think you have to put it in the slide view.
Yeah, so it seems like it is coming on the second
Good.
screen.
You're good now.
Okay. Thank you. Today, the agenda is I would like to discuss on these topics like advanced data warehouse management strategies. What is Teradata? And why Teradata and how it stands out of other databases in the market. Also, what is performance tuning and why it matters. Optimization strategies for performance tuning and innovative solutions on performance tuning. Coming to the advanced data warehouse management strategies, there are tons of management strategies for the data warehousing. Among them, I have picked up like 15 items which were plays a major role in advanced data warehouse management strategies. These items will play a key role in your warehouse management. They are data integration, ETL process optimization, data quality management, and so on. I will go briefly on each one of them, what is what, and then we will move to the next slide. So first and foremost thing is data integration is nothing but like merging data from various sources into a unified repository for easier access and analysis. Let's say your data is coming from different sources and you want to club all of them together, make it one single data warehouse. For the business easiest analysis, we can make it easily by following this strategy. And ETL process optimization is like streamlining the extraction, transformation, and the loading process to ensure faster data ingestion and transformation. Like transforming, loading the data, and processing the data as per the business requirements in very faster way to ingest the data into your target database warehouse. We will follow this ETL process optimization. And the data quality management is nothing but implementing robust quality checks to ensure data accuracy and consistency and completeness. Also, metadata management is organizing and tracking the data context lineage and usage to facilitate efficient data retrieval. Real-time data processing, leveraging technologies like stream processing for immediate insights rather than relying on batch processing. And cloud-based data warehousing is utilizing cloud infrastructure for scalable, cost-effective data storage and computation. Nowadays, in the outside world, we are hearing in so many corporate companies like utilizing the cloud-based data warehousing, where you can reduce your cost-effective by storing the data into cloud databases. And data governance, like establishing the policies of data security, privacy, and compliance with regulatories. So where your data can be secured without any leakage and also without any damage to your data. And also performance tuning, like optimizing query performance using indexing, partitioning, and data caching techniques. I would like to go through this in detail for performance tuning in the next slide, which is very important for the database administrator and the database, for any database systems. And data virtualization, providing a unified view of data across disparate systems without physically moving it. So instead of moving your data from one place to another place, so this is data virtualization will help you keeping physically in one location, but it disparates the system to the other sources, improving the agility. And advanced advanced analytics is integrating machine learning and artificial intelligence for predictive analytics and actionable insights. And data archiving, this is like implementing the strategy for archiving the historical data while keeping it accessible for long-term use. So we can archive the data, historical data, by following data archiving different types of strategies, so that historical data can be maintained, and at the same time it is still accessible to the business users or the end users as well. Data security, using encryption, access controls, and authentication mechanism to protect sensitive data. So with the strategy of data security, you can encrypt the data where the user cannot understand, which is only machine learning understandable way. And the access controls, the access of the users can be limited or can be completely unauthenticated to control the access and disclosing the data mechanism to protect sensitive data. And the user self-service is like empowering business users with the tools to query and analyze data without IT intervention. And the last but not the least is scalability. Scalability is like designing the data warehouse infrastructure to handle increasing the volume of data and more complex queries. So this scalability also plays a major role where there we can expect that the business will grow. As the business grows, your company data also will grow up. So during that time, it is easy for scale up and scale down based on the data volume that is coming into your company. Yeah, these are the management strategies. And moving to the next one, to the Teradata. So Teradata is a kind of another relational database management system with the high performance capability and a massively parallel processing feature called as MPP, designed for large scale data warehousing and analytics. It is particularly known for its ability to handle large volume of data, provide real-time analytics, and scale horizontally to meet the growing demands of enterprise. So in the current market, Teradata is a robust database system where it gives the high performance for the users. And moving to the next one, like why Teradata and how it stands out of other databases in the market. So Teradata is a leading database system, particularly known for its data warehousing and analytical capabilities. It stands out from other databases due to several key features. There are tons of key features actually for this one, but here I have picked only 6 major key features which plays an important role in Teradata. That is massively parallel processing and optimization, scalability and flexibility, shared nothing architecture, security and compliance, analytics and business intelligence tools, cloud and hybrid solutions. Apart from these 6, we have other tons of other key features as well. But here I'm going to discuss these 6 high priority and highly high feature things here. I'm trying to share those details. Massively parallel processing is also called as MPP, and optimization as well is the main feature of Teradata. It is parallel processing and optimization capabilities. Teradata uses massive parallel processing architecture, which distributes the data and workload across multiple nodes and processors. This allows Teradata to execute queries very faster, more efficiently, and more accurately than traditional databases. This is a unique feature that it possesses in the Teradata, but we don't see these kind of feature in other databases in the current market. So Teradata also uses advanced optimization techniques such as join indexes, hash indexes, aggregate join indexes, and the compression to enhance the query performance and reduce the storage space as well. And the scalability and flexibility is the another benefit of this Teradata is it's a scalability and flexibility. Teradata can scale up or down depending on the data of the volume and workload without compromising the performance or reliability by adding more nodes to the system without major disruption. So Teradata also supports a variety of data types, formats, and sources, including structured, semi-structured, and unstructured data. This means that Teradata can integrate and analyze data from different systems, applications, and platforms such as ERP, Enterprise Resource Planning, CRM, Custom Relationship Management, web and social media, etc., etc. It can handle petabytes of data across hundreds or even thousands of nodes. The third feature is shared nothing architecture. This is a unique feature in this database. Like, each node in Teradata system has its own CPU, memory, and storage, ensuring there are no resources bottlenecks. There are no resource bottlenecks. So if any one of them is not performing well, it doesn't affect the other nodes because every node has its own CPU, memory, and storage as well. So this design allows for fault tolerance and better performance compared to shared architecture. So this is shared nothing architecture will not lose any data during the processing time if any one of the node goes down. That is called as fault tolerance and better performance compared to the shared architecture. Security and compliance. Security and compliance is also offers security and compliance feature that protects the data and the users. Teradata supports encryption, authentication, authorization auditing, and masking to ensure the data confidentiality, integrity, and availability. So Teradata also complies with various industry standards and regulations such as GDPR, HIPAA, GDPR in the sense General Data Protection Regulations, and HIPAA is Health Insurance Probability and Accountability Act. Also in PCI DSS, Payment Card Industry Data Security Standard, and SOX, Sarbanes-Oxley Act, to meet the data governance and privacy requirement. And moving to the next one, analytics and business intelligence tools. Advanced analytics and business intelligence tools. Here, Teradata is not just a transactional system, but also it excels in advanced analytics such as machine learning, predictive analytics, and large-scale data mining. It integrates well with data science tools like Python and Teradata Aster. Teradata Aster is a different tool, that internal tool that Teradata provides for in-database analytics. Teradata also provides a range of analytics and business intelligence tools that enable the users to access, explore, and visualize the data. Teradata offers native SQL and business intelligence tools such as Teradata SQL Assistant, Teradata Studio, and Teradata Viewpoint, as well as integration with the third-party tools as well. So there are specific tools that where Teradata offers, like SQL Assistant, Studio, and Viewpoint. Using those tools, you can start doing the analysis of data, and you can generate analytical reports, something like that, such as Tableau, Power BI, SAS, and R. So these tools allow the users to create reports, dashboards, charts, and graphs to discover pattern, trends, and insights from the data. Sixth one, last but not least, is cloud and hybrid solutions. Teradata also offers cloud and hybrid solutions that gives the users more flexibility and convenience. Teradata can be deployed on premises or on the cloud or on a hybrid model, in any one of that way, depending on the business needs and preferences. Teradata supports various cloud platforms such as AWS, Azure, and Google Cloud, as well as its own cloud service, Teradata Vantage. So, like AWS, Azure, and Google Cloud, Teradata is having their own cloud service called as Teradata Vantage. So it can be deployed in any other premises as well. These solutions allow users to enjoy the benefit of Teradata without the hassle of managing the infrastructure, hardware, and software. Teradata is a powerful and versatile database platform that can help business leverage their data for business intelligence. Teradata can handle large and complex data sets, delivering fast and accurate query results, ensuring data security and compliance, provides analytic and BI tools, and offers cloud and hybrid options as well. By using this Teradata for business intelligence, business can gain a competitive edge to improve customer satisfaction and increase revenue. So we have a lot of advantages by using this Teradata. That's why with these key features of these, this is how it stands out of the market in the current data. In the current database markets, actually, there are lots of other tons of other key features as well, like data distribution and parallelism, columnar and row-based storage, SQL compatibility, workload management, data warehouse, and so on. So there are tons of features out there. But here, these are the 6 very major key features which it makes you stand out from the other databases. Yeah. Moving to the next topic, optimization strategies. So we have different optimization strategies. One is query optimization, workload management, data compression, join strategy optimization, partitioning large tables, compression, workload management, proper indexing. There are other optimizing strategies, but here I'm going to discuss about query optimization, workload management, and data compression, and a few other details. So coming to the first, optimizing query design or query optimization is like writing efficient SQL queries that minimize the resource intensive operation, such as full table scans, and avoid unnecessary data retrieval. So optimizing of a query is nothing but minimizing the resource intensive operations. Like instead of scanning the full table, gathering only the required information from the table by using the right index and avoiding unnecessary data retrieval. So you can use explain plans to analyze and optimize the query execution as well. Yeah, so that's how the optimization query design can be done using this technique. Proper indexing or workload management is like configuring Teradata workload management tools to prioritize critical tasks. Like use a Teradata active system management, which is called as TASM, to allocate resources dynamically across workloads. This ensures that high priority queries are prioritized while preventing resource starvation for lower priority tasks. So you can prioritize the queries on your database based on the level of importance for the query and the data in your business. And data compression is a kind of technique that is applied on the data to compress the data uh, uh, to um, uh, to compress the data in order to reduce the storage and improve the input output efficiency. Like let's say for an example, in any column, if you have very minimal number of unique key values, then you can compress those unique key values, storing in the table header. So that instead of populating the entire data into the entire table, like if you have millions of records, instead of populating that million number of times, you can compress that value and keep that value in the table header. This is one of the best data compression technique in database. Um, Also, there are other features like join strategy optimization, partitioning large tables, data distribution optimization, efficient use of temporary tables. Yeah, there are different types of other strategies as well. We can follow those strategies to optimize your query performance. Moving on to the next slide. Here is the performance tuning technique. So first of all, what is the performance tuning in database? Performance tuning in database refers to the process of optimizing and improving the performance of database system. The goal of performance tuning is to ensure that the queries run as efficiently as possible, minimizing the response time and maximizing the resource utilization. That is what the performance tuning refers to the database. With the using the performance tuning techniques, you can save lots of money for your company, like saving the minimizing the storage and minimizing the CPU consumption on the database, minimizing the input output triggerings, all those kind of things. So there are several performance tuning techniques are there. Here I'm going to discuss all these 11 performance tuning techniques here. Understand the explain plan using primary and secondary indexes wisely, optimize joins, reduce data movements, collect and maintain the statistics, leveraging partitioning, streamline aggregation, use volatile and derived tables, avoid nested subqueries, avoid product and quotation product joins, monitor and optimize the spool usage. I will briefly explain each and every item here. Yeah. So we can master in database by using the performance tuning techniques, and these are the best practices for SQL optimization that I have come up with. Um, we know that why performance tuning matters. Like efficient SQL queries are backbones of any driven application. Poorly optimized queries can lead to excessive CPU and IO usage, longer response times, increased system cost due to inefficient resource utilization. All these kind of drawbacks will happen if your query is not optimized properly. So as I explained earlier, following those 11 performance tuning techniques, you can overcome these excessive CPU and IO, longer response time. Instead of waiting for long response time, you can quickly get the result set by following all these techniques. Like understanding the explain plan. Explain plan is a sequence of steps that the optimizer gives from the database, like full table scans, redistribution steps, school usage, all these kind of details. In detail explanation will be there in each and every explain plan, which is generated by the database itself. Number two is second technique, like use primary and secondary indexes wisely. These indexes are defined on top of the table where it is called as a key columns. Using those key columns as a primary and secondary indexes, the retrieval of data is going to be very faster. Also, the third technique is optimizing the joins. When you are trying to join from between two or more tables, we will try to use the primary indexes where it is directly going to the table and the location of the specific data and retrieve the data from there instead of having the full table scales or something else. That is another third technique, which will retrieve the data very fastly, even though if the table is having a huge amount of data, like terabytes of data also, it can retrieve in very less amount of time. Reducing data movements, like minimizing the data redistribution across AMPs. Access module processor is another one of the key feature that is in Teradata. So instead of moving the data between the AMPs, reducing the data movements is also another technique that where the performance will be higher in the query performance. Collecting and maintaining the statistics is another technique. Statistics is nothing but which gives the demographic information of the query, like how many unique values are there, what are the indexes on the columns, how many rows will be retrieved, all those kind of demographic information will be given. But you have to keep collecting that statistics to make understand by the optimizer very well, and it will generate a quicker plan to give the result output quickly. Another one is leveraging partitioning. Let's say, for example, your table is very big, and instead of scanning the entire table, partition the table into different partitions and retrieval only that partitioned data as per our requirement. Avoid unnecessary partitions to reduce maintenance overhead. There are different types of partitionings are there. Range or hash partitioning based on the query patterns. Streamlining the aggregations is another technique, like aggregate functions like sum, count, average can be reduced in resource intensive. Use volatile and derived tables. Volatile and derived tables are the temporary tables that can be generated in your query, where the intermediate result set can be storing in these two tables and perform the query as per the business requirement and output the result as quickly as possible. Other things that we have to take care is avoiding the nested subqueries. Nested subqueries are not good for the any join queries or something like that. And also monitor and optimize the spools usage, like avoid select usage where class. Tools and performance tuning. These are the different tools of performance tuning techniques, which I discussed earlier: Teradata Viewpoint, Teradata Studio, Pima. With this, I'm wrapping up with my discussion that I have given the good key points for the performance tuning technique.